In the present video, we're going to present examples of parametric plots in SMAS Studio. Just a brief introduction to give you an idea how to do them. We're going to be presenting in more detail in a future video. At this point, we want to go onto SMAS Studio, and we're going to look at a couple of equations here. X1 and Y1 functions of t. T is the parameter. T is the parameter, and as you can see, for each one of those curves, we have a sine function and a cosine function. So we should be able to complete a plot of these functions if we use values of t that I'm going to call tt as a range, starting from 0, comma, ending in 2 times p control g to pi, spacebar, comma, p control g divided by 100. What I'm doing here is creating a vector of the parameter t. I'm going to put it over here. Going every 100th of pi out to 2 pi, so we complete a complete round of values of t. Now we're going to produce vectors x1, I'm going to call it, that are going to evaluate x dot 1 of t spacebar, and we use the vectorization. Then y1 with a column y dot 1 parenthesis of t. I forgot. I need to select the right hand side. In here, I put a p, should be a tt, that's the vector of values of t. Just to check on that, we're going to do length of x as 1. We have 200 points. Length of y1 equal to 200 points too. I'm going to keep this over here. Then we're going to create an x2, x dot 2 parenthesis tt spacebar vectorization to obtain a vector of values of xx2, yy2, colon y dot 2 parenthesis tt spacebar vectorization. And just to check, I'm just going to copy this, Control C, put it over here, Control V, and change that 1 to 2, and indeed we had 200 points. Now what I can do is produce a matrix that's my augmented. I'm going to call it mx1, augment xx1 with yy1, and we could try size. Wait, actually, no, it's not size. I'm going to try the rows of mx1, 200, and columns of mx1, 2. That's because 1 is for x, 1 is for y. By the same token, I'm going to just do Control C, click over here, Control V, and change all the 1s in there for 2s. When you click over that, you get the cursor between the y and the 1, and you have to move it to the right with the arrow, and then delete and replace with the 2. If I now copy this, Control copy, and change this to 2, I obtain the same numbers. That's good. Basically, I don't need these things. I was only checking the sizes of those vectors, and I don't need this. This is sizes of the matrices. What I'm going to do here is use an insert plot, xy plot, and I'm going to put my mx1 here. Now the limits I have in the graph are not enough to show the ellipse that constitutes this graph, and so I'm going to change the vertical axis. I'm going to put from -5 to 5 also, like the x-axis. So I double click on here, go to the y-axis, I'm going to keep one decimal place here. Maximum of 5, minimum of -5, with increments of 2.5 as we have for x. Okay, so now we start saying that ellipse more clearly. Still, the length of this axis is 10 units. It's not the same as this one, so we're going to, by I, sort of make it as square as possible. And that will be the actual size of my matrix. Now I'm going to do a select here, Control C, click over here, Control V, and I'm going to change this to an MX2. And you get a different shape ellipse. If I want to put the two graphics together in the same plot, I'm going to select this, do Control C, right here in the middle, do Control V, and then select MX1, go to the system of equations icon, and type MX2. And there you get the two parametric graphics shown together. This is just a simple example to give you an idea how you're going to handle parametric graphics. And if you want to place here a legend, you have to double click on the graph and go to the traces, because we're going to have to give a name, and let's call that ellipse 1 E1, just to give it any name, just to show you how these things are going to work. Ellipse 2 E2, okay. Then we go to legend, open it up, and is legend visible? We say true, and then we got that in there. It's a little bit big, covering the graphics, so we could try to stretch this, but trying to keep that equal length of x and y to show the two parametric equations. And that's the way that you're going to handle parametric equations. Later on, we're going to talk about polar coordinates. And polar coordinates, it's a parametric set of equations because we're going to have a function rf of theta, and then we're going to find the coordinate x, which is r times cosine of theta. And since r is f of theta, then we're going to replace this. And also we're going to have for y f of theta. Theta, by the way, is q control g, spacebar times sine of q. And so that way we can produce a set of polar coordinates to show in our screen. And so I'm going to give you a quick example here. In the next page, I'm going to define a r of theta as, let's say, 2 times cosine of theta. And then I'm going to use these expressions to define my x of theta and my y. I'm just going to copy from here. Okay, I'm going to produce my q control g theta theta as a range again between 0 and 2 times p control g spacebar comma p control g over 100, just like we did before with t. Now we're going to have angles going from 0 to 2 pi in increments of 100. And then I'm going to produce my xx as x of q control g spacebar vectorization, and y of q control g spacebar vectorization. Now I'm going to create a matrix augment, and down below here I'm going to introduce insert plot, XY plot, and down below I'm going to type M of XY. Now, because of these two here, the values of R could go from -2 to 2, and apparently they're not enough to show in here. I'm going to check on the minimum and maximum values. I'm going to interrupt. I'm having a problem here. I'm going to interrupt the calculation. I'm going to delete this. And I'm going to pause the video recording for a minute to check what's going on with this information. Well, what's going on is that I've used an F of theta here instead of R of theta. And of course, I wasn't calculating anything. So now if I say, oh, now I got something here. Going from -1 to 1 and from 0 to 2. This is a circle, actually. And I'm going to make it more complicated. I'm going to delete this cosine control. I'm going to copy Control X, cut it, actually, put a parenthesis 1 minus cosine of theta. And that's going to give me a different type of plot. Actually, we're going to calculate here where is the minimum of XX and the maximum of XX, minimum of YY, and the maximum. So we go from -4 to 0.5, pretty much, and from -2.6 to 2.6. So I'm going to change my X -4 to 0. Okay. Sorry. Click over here. Click in the middle. X. We're going to go from -4 to 1. To 2. Say -4 to 2. Put 6 units in the X, and then in Y, we're going to put -3 to +3. The increment is going to put 1 in here. And also in terms of X, I'm going to put 1 too. Okay, so that's what's called a cardioid, a heart-shaped figure. Now, I have the same number of units, 6 in the vertical, 6 in the horizontal, but it's not very square. I'm going to drag it out, down this way, and try to make it as square as possible. So what we produce there is the shape of a cardioid. It's another type of parametric equation, but this time based on a variation of the radial coordinate r as a function of the angular coordinate theta, and then using these formulas for converting polar to Cartesian coordinates to produce my x and y coordinate. And so with these two examples, I'm concluding this brief introduction to plotting parametric equations in SMAT Studio.